Good day and welcome back to Rinalwena Education. Today we're going to discuss Newton's laws of motion, grade 12. Please consider the following cases. We're going to talk about normal force today, incorporating it with different cases. Case number 1, we have an object pulled on a horizontal surface. We want to know what is a normal force of this kind of object. Do we have normal force being equal to weight, or do we have normal force being equal to some component? Let us draw what we call a free body diagram first. All right, so we're going to start with our free body diagram. So this is our free body diagram. I'm going to represent the block with a dot. I'm going to represent a block with a what? With a dot. Then I will call this my, I'll call this my normal force. I'll call this my weight. Then I'm gonna call this what? I'm gonna call this my force applied. This is my force applied. Then this depends whether we have a horizontal surface, a rough surface or smooth surface. For this case, let's say our surface is rough. For argument's sake, let's say our surface is just rough. Okay, so that means if I have a rough surface, I'm gonna have what we call a frictional force there. So this is my frictional force. So that means if I note down, I'm gonna have my normal force, I'm gonna have my weight, I'm gonna have my force applied, and I'm gonna have my frictional force. Now, since this object, it is lying on a horizontal surface, that means by law, normal force, it is equals to mg, which is equals to fg. Or if you like, you can say normal force is equals to fg, which is equals to mg there. Where my m, it is just mass, the mass of the object, then my g, it is just gravitational acceleration. So my gravitational acceleration, it is given as 9,8 meters per second squared. There. I hope you're happy with this. So normal force for the surface that is horizontal, it is just equals to weight. So that means these two forces balance each other. That means normal force is equals to how much? It is just equals to weight. Then, so please note this down. Now let us check another case. Let's call this case 2. We can say object pulled at an angle. Object pulled at an angle there. Object pulled at an angle. You can say object pulled at an angle. Let me just fix this. I'm gonna fix this here. I'm gonna say object pulled at an angle. So my object pulled at an angle, we want to see that normal force, it is equals to weight, as in case 1. Is that true? Is normal force equals to weight here? Absolutely not. Let us draw our free body diagram. I am just gonna take this one like this. Just gonna do this. To save time, I'm just gonna take this one and paste it here. Okay, let us check this one. Now let's take, for argument's sake, that our surface is rough. Okay, we have a rough surface. That means there is frictional force. So now, since our force it is pulled at an angle, we're gonna rub this off like so. That means our force it is at an angle. Our force it is at an angle there. Our force it is at an angle. So now I know that I have my, let me be consistent. Let me use a blue color here. My force it is at an angle. Now I wanna check, is normal force equals to Fg. This is my force applied. This is my frictional force since we have a rough horizontal surface. We cannot say normal force is equals to weight for this case because this force it is pulled at an angle. That means they exist components which goes hand in hand with this force applied. So we need to draw our component system there. I'm going to draw my component here. So this will be my component, first component, then that will be my second component there. So this is my vertical component. Let me call it FV. This is my horizontal component there. So now forces which act vertically, how many are they? Let us count them. We're gonna have force 1 which is normal force 2 which is FV, force 3 which is FG. Now let's take up as positive and down as what? And down as negative. So everything that goes up is positive. So I'm gonna say normal force plus FV, it gives me what? It gives me FG, because I know that if I add these two forces, I'm gonna get this force. So normal force plus FV, it gives me what? FG. So now I know that my normal force, it is just mg. I know that my normal force, it is just mg. But my FV, it is equals to F sine of theta. Then my FG, it is just mg. Okay, so now let us check how can we find sorry, I made a mistake here. This should be normal force. This should be normal force. Now I want to make n the subject of the formula. So that means my normal force will be equals to mg minus force applied sine of theta then. This is my what? This is my formula for normal force. And you can see that normal force being equals to mg minus f sine of theta cannot be equals to what? Cannot be equals to fg. So that means normal force, it is not equals to fg, but rather it is equals to mg minus f sine theta then. All right, this is the formula for normal force for this case. But if fh is equals to f sine theta, fv is equals to, if fv is equals to f sine theta, meaning fh is equals to f cos of theta. So this is our horizontal, then this is our what? Fv is f sine theta, which is our what? Our vertical there. I hope this is clear. Now our normal force is just equals to mg minus f sine theta there. Now what about our inclined plane? We call this case 3. It is called inclined plane. Let us draw normal force for this one. So I'm gonna draw my block as a dot there. Now this is my normal force, okay, because my block is facing this direction, but my weight, it always acts perpendicular to the surface. It always acts perpendicular to the surface. Now, my force applied, it's like so. Now, this is a rough horizontal surface, then I should have frictional force there. So meaning this is my normal force. Sorry. This is my normal force. This is my Fg. This is my force applied. This is my frictional force. Now, since we have an angle here, we need to draw our component system. So now we're going to have our first component there and another component there. We have our first component there, then another component there. Okay, another component there. So now for this case, on your inclined plane, normal force, it is equals to Fg cos of theta. But we know that Fg is just equals to mg cos of theta there. So now this is your normal force when you are dealing with an inclined plane. So normal force, it is equals to F g cos of theta